and welcome back to Biostat Squid. In this video we're going to learn how to create and customize a heat map with our package ComplexHeatmap. So if you're ready, let's dive in. ComplexHeatmap is one of the most powerful and flexible OR packages for creating publication quality heat maps. It allows you to add multiple layers of annotations and customize basically every aspect of your plot. So if you want to create professional looking figures, I would really recommend this package. Once you learn the basics, it's really easy to customize your heat map. Anyways, if you're not too sure of what a heat map is or if it's the right visualization for your data, I remind you I have another video and blog post on heat maps, so check it out. Otherwise, let's dive right into it. Okay, so we'll start by cleaning our environment and loading the necessary packages. We need the package ComplexHeatmap, of course, and Circlize, and you might want to load our color brewer as well for colors. There might be a couple more packages you need throughout this tutorial for different customizations, but these are the basics. So we're going to create some patient data just to be able to plot it, but if you've got your own data set, feel free to skip steps 1 and 2 and go directly into heat map creation. But essentially, the first step is creating a realistic data set simulating gene expression data from cancer patients. So we're just going to run these lines. And as you can see, we have genes as row names. You'll have the different actual gene names, and then patients or sample IDs as column names. And we have 100 genes and 50 patients. Now, you can be plotting something completely different, and you can have different dimensions of your data set as well. So there's no limit as to the dimensions a heat map should have. What's important though is that this object should be a matrix. So you can check that by calling class. And as you can see, it is a matrix because I created it with this function over here. So if you have a data frame, you can easily convert it to a matrix using as matrix and just apply it to your data frame, and then you'll have a matrix. I should say as well, if you want to plot things the other way around, so if you want your samples to be rows and your columns to be genes, that's totally possible and totally fine as well. You can easily convert that by calling transpose on your matrix. So I'm just going to show you how this would look like. Oops, I don't have the package tidyverse. I'm just going to show you a couple of columns and rows. So as you can see now with transpose, I now have genes as columns and patients as rows. You can also use this in the actual heat map function, but I prefer to do it on the actual data set that we're then going to give to our heat map function. But anyway, up to you. Great. So next we're going to create some patient annotations. So you might want to add annotations to your heat map, for example, to track information about the patients, like their age or their cancer stage, or to mark gene information if you want annotations for your genes. For example, if certain genes are related to specific pathways or whatever it is. So we're just going to create an annotation data frame. There we go. So it looks like this. So you can see the patient IDs, and they should kind of match the same IDs we had as the heat map columns. Then we have age, BMI, tumor size. Anyway, they're just some made up values, annotations for our samples. So it's important that this the patient IDs are, or the row names of this data frame match the column or the row names of your heat map matrix. So in this case, we're going to set the patient IDs as row names. So patient annotations, patient ID. So as you can see, if I now print this again, We have the patient IDs as row names, and they match the column names of our heat map matrix of our expression data. Great. So just a quick note, if you're using Seurat expression data, so you have a Seurat object, you can get the expression matrix with get assay data from Seurat. Just a quick note there. But anyway, we're ready to create our first heat map. So let's start with a simple heat map to understand the basics. So ComplexHeatmap has this function called heatmap. If you want to know more, you know that you can call help and it will give you more information about this function. But essentially, we see that the first argument is our expression data. So the actual values, the actual matrix with the values you want to plot. So in our case, the values we want to plot are contained in the object expression data. Next, we have the name of the heat map. So I'm just going to call it expression. And you can decide whether you're going to show the row names and the column names. I decided not to show the row names, but I will show the patient IDs. And with this GP, you can control the font size and other characteristics of the annotations. Nice. So let's just run that. Now, when you run heatmap, this will create an object. So it's an object of class heatmap. And if you open it up, it has like a lot of information, a lot of data telling what the heat map looks like and what are its components. But to actually visualize the heat map, we need to call the function draw. So let's just do that. And there we go. We have our first heat map. So you can see that we have our patients as rows and our genes as columns. Sorry, the other way around. But we decided not to show the row names, so the gene names are hidden. These are the default colors for our heat map. You can see the expression values here, but we can also customize that. And we have the title of our heat map, which we defined with column title. And as you can see, our heat map is clustered, meaning that rows and columns are grouped by their similarity in gene expression values. We'll see in just a minute how we can control this. We can control how the grouping is done, or if we want to disable it completely. And the dendrograms here on the sides show the relationships between samples and features, genes in this case. Nice. So let's start talking about color. Color choice is crucial for effective data visualization, and more so in a heat map where you're actually using color to plot values. So you can explore different color schemes and you can decide which colors best apply to your data or are best used to show what you want to show. And I just want to recommend Color Ramp 2 from the OR package Circlize, the one we loaded up here, because it allows you to create color palettes really easily. The way it works is you define your minimum, maximum, and your midpoint value, and it will create a palette, a continuous palette that goes from minimum to maximum, and the midpoint color matches your midpoint value essentially. So you can check what's the minimum value in your data set with min. So you would probably want to do that. So actually I might just adjust this to 6 so that the colors better match our scale of values or our value range. Let me just check the maximum value. So yeah, around 6. So I could probably set this to 7 even, or 6.2. But anyway, let's just leave it like this. And our Color Brewer also has different palettes. So I'm just loading the spectral palette. But yeah, you can explore these tools further. We can have a look like this. Or actually lets you have a look at the values. So yeah, this is the spectral value, but there are different values, palettes depending on what you want to do. So essentially the color of the heat map is defined by the argument col. So that's over here. So we're just going to set this first palette as our heat map colors. We'll also edit the heatmap legend with this heatmap legend parameter, which is a list. So we can set our own title, we can set the legend direction, the legend width. Anyway, there's many things you can customize. So I'm just going to show you a couple. So let's just have a look. And of course, if we want to actually see our changes, we need to call the function draw. So yeah, nice. We used a different color palette. Here we go. And as you can see, the legend direction is horizontal. And if you want the heatmap legend side to be in the bottom, you have to specify it when you call the function draw. Otherwise, you can say left, for example. It will still be horizontal, but it will be on the left side of the heat map. Nice. So we mentioned clustering before. Now, the clustering system allows independent control over rows and columns, and it supports different distance metrics and different customization if you want to do custom clustering, or if you want to use a specific method or a specific distance metric to cluster your rows, columns, or both, or neither. So you can have a look if you call the help heat map. Where's this? I don't know what I did there. Heat map. Oh my goodness. Okay. So here you go. For example, here you have distance. There's different distances. You have Euclidean, Manhattan, Pearson or Spearman, binary. Anyway, there's different distance metrics, and you have different clustering methods as well. I usually use distance Spearman, and the clustering method Ward D2. Ward D2. But you can read more on these methods and distance metrics to figure out which one works best with your own data. So Ward D2 will minimize within cluster variance, which is often preferred for gene expression. And then Spearman is a correlation-based distance for expression data. So I quite like them when I'm dealing with gene expression data. I'm going to change this back to bottom again. So yeah, you can play around with the different clustering methods and distances to see how it changes. Nice. So now that we have the basics, it's time to add some annotations to our heat map. This is where a complex heat map really shines. There's so many customization options. So let's start by adding annotations to our samples or patients. First, I like to create a color list, basically setting the colors for our annotations. Now, this is not necessary. If you don't specify colors, Complex Heat Map will choose a palette for you, but it might change every time you run the heat map. So I like to set them myself. Note that for continuous variables like age, we're setting them with color ramp 2, but for discrete variables like gender, male or female, we're setting them manually, or not manually, but we're setting discrete values for each of the categories. Nice. So the important part is creating a heat map annotation object. So now we're not talking about the heat map function, it's called heat map annotation. So we basically first define the annotation tracks, one for each variable we want to plot. Note that if you have many variables, many annotation variables, you can directly specify a data frame. So you could potentially say df equals patient annotations, and set the whole patient annotations data frame as your heat map annotations track, let's say. But the thing is, there might be certain columns we don't want to plot. So that's why, if you prefer, you can actually define them one by one. So that's what we're doing here. Nice. Then we have call for the colors. So in this case, I'm just giving it our color list. Note that even if you add more or less, that's fine. It will just use the ones it has. So imagine we don't set a color for age, it would still work, and it would give, it would set automatic colors for age. Again, GP's graphical parameters, so this controls the annotation name in this case, and then this controls the legend. So as you can see, you can, even if the column is called tumor size, you can edit the name of the annotation in the legend. So let's just show this. I forgot to load the color list. Perfect. And now again, we call heatmap, and here we can decide that the annotations will be shown in the top. If you wanted them in the bottom, then you say bottom annotation, or left annotation, or right annotation. Although in this case, since the annotation refers to our patients, which are our different columns, it will have to be top or bottom. Otherwise, it will give us an error if we try to set it to a left annotation. But let's try that. Nice. So here we go. These are our annotations with very striking colors. And as you can see, we have the legend over here. You can see age, years, tumor size in centimeters. So you can totally edit this. You can edit where the legend is placed as well as the heat map legend. Note that there are two separate things. One thing is the legend for the annotations, and the other thing is the legend for the heat map itself. So they're controlled separately. That's important to note. If you'd like, you can also separate them. So here we're going to just change the colors a bit, and now we're going to set a column annotation for the top and one for the bottom. So I'm going to call this top annotation. And in top annotation, I'm just going to place age, BMI, tumor size, and gender. So let me just run that. And for the bottom annotation, I'll set the other variables. Great. So now in our heatmap function, we set the top annotation as top annotation. So the heatmap annotation object we defined here. So this will be shown in the top of the heatmap, and this will be shown in the bottom of the heatmap because it's here. Great. So let's just run that. I need to change this to Spearman. There we go. So now we split our annotations in top and bottom annotations. So really easy to decide where you want to place your annotations. Great. Of course, the same applies to rows. So we can also add annotations to our genes. So I'm just going to create some categories for the genes related to pathways and their function. I'm just going to make it up. Let's just create gene categories, which is a data frame. And just like before, make sure your row names are gene names. I think it would actually work without, but I like to make sure they're in the same order, because otherwise you might get annotations added to the wrong feature or the wrong sample. So let me just set the row names. I think there's a dot here. And now if we call head, there we go. Now we have gene names as row names. So yeah, each gene, I mean, this is completely arbitrary, but each gene has a pathway and a function. So now we set annotation, and note that this time I set row annotation. Now we could set it to heatmap annotation, that would work as well, but this is another way you can use the annotation. So instead of heatmap annotation, you can set it explicitly to row annotation or column annotation. In this case, the bottom and the top annotations we had before, these would be column annotations. And here, because we're annotating our genes, so our rows, we set it to row annotation. So easy. Again, we set the different annotations here explicitly. Again, if you wanted the whole data set, then we would just say df equals gene categories. Then we set the colors. So here I'm setting the colors inside the function, but you could also create a separate color list and just pass it on to call. So call controls the colors and yeah, graphical parameters and the legend. If you want to find out more about row annotations, you can always Google or use AI to figure out how to do certain things. But otherwise, yeah, you can find out how to customize it even more. Let's now create a new heat map. So again, our expression data, the name of the heat map. Then we have, this was going to be wrong again. Here we go. Then we have our colors. This time I'm going to set it to our other set of colors. And then we have a top annotation. So that's top annotation. Then we have the bottom annotation and our left annotation. So we're going to set the gene annotations to our left. And we're not going to show our row names, but we are going to show our column names. Then you can also control how the column names are displayed by adding a rotation or an angle, so 45-degree angle. You can decide whether the column annotations, so patient 1, patient 2, etc., if they're displayed in the top or the bottom. And again, the graphical parameters allows you to control how that looks. So yeah, plenty of ways to customize this. So let's just run this. Nice. So let's see, this looks already really professional. So as you can see, we have a rotation, a 45-degree angle of our annotation rows and columns. Then we have our legends and we have our row annotations here. So as you can see, we have the pathway and function. You can control whether these are displayed or what they say. You can also control these colors or if there's a border or not. You can control whether this is shown or not. But wait a minute, what happened with this? Why is the heat map split into groups? Well, this is actually controlled by column split and row split. And there are different ways you can do this. One example is splitting by stage or pathway. So note that in this case, it's literally splitting patients that have the same, stage, so cancer stage. And within each cancer stage, it's clustering, but it's doing the clustering within each cancer stage. So it's not done on the whole data set, if that makes sense. And this is important because it's not completely unsupervised clustering. It's unsupervised within each cancer stage. And the same happens with the genes. We first group them based on the pathway, and then we do unsupervised clustering. So that's one way you can split the heat map. Of course, instead of this, you can use these parameters over here, k-means clustering, to decide whether you want to split it by a certain number of clusters. So I think this should work. Let's have a look. So as we see here, now there's complete unsupervised clustering for both patients and genes. And I just decided that there should be 3 groups, essentially. So that's what it did. And it did it based on the dendrogram. And you can see the dotted line here, which will show what level at which level it's cutting the dendrogram to create this split in our heat map. So you can play around with that. You can also control how wide the gap is, and so on. And you can do it for both rows and columns. So to recap, you can cluster your heat map or not, but if you do clustering, it can be completely unsupervised if you don't know what groups you're expecting. But if you already know certain groupings like patient subtypes or treatment or tissue types, then splitting lets you show those categories explicitly and cluster within each group. It depends a bit what you want to show. But remember that splitting overrides that clustering across the full data set and instead clusters within each split group. So if you want to discover natural groupings via unsupervised clustering, do not split. Great. So one of the best things about ComplexHeatmap is that it allows you to add all kinds of plots to the main heat map as annotations. For example, it supports complex annotations types like bar plots, which are perfect for showing compositional data. So let's start by creating a data frame with the proportions of cell types for each tumor sample. So it looks like this. So we have the different patients and then the different proportions of tumor cells, T cells, macrophages, and B cells in that sample. So we'll start by setting the colors. And now the way the bar plot annotation works is it is also a heat map annotation, but instead of just setting the different annotation columns like we were doing before, we set a specific type of annotation called anno bar plot because we want to draw a bar plot. So this is the name of the annotation. So we'll see how later when we plot it in the heat map, it will say that this annotation is called cell composition. You can call it whatever you want. If you want spaces, then don't forget to use the special characters, the commas, the special commas, so that or understands that this is a word, let's say. So anno bar plot will take our data frame. In this case, we just want to select the cell types of interest. So this is the data frame we're giving it, our different patient IDs, and then tumor, T cells, macrophages, and B cells. Now, graphical parameters, we're just specifying the fill color, so our cell colors. And this is the border color, white. And again, you can control the width, the height, anything you want. So if in doubt, just check the official documentation, because there's many ways you can customize the bar plot annotations. But let's try and draw the annotation. So we're not drawing the entire heat map, we're just drawing the annotation. So you might want to call dev off first, because otherwise it might be a bit weird. So yeah, we're just showing our bar plot annotation, which is here. It's a bit cropped. It actually works so much better when you plot it with the heat map. But as you can see, or more or less guess, there are different bar plots which with our proportions of cell types per patient or per sample. So let's just turn that off, and now we're going to add it to our heat map. So we have again our expression data, clustering, the color of our heat map, top annotation, left annotation, and now the top annotation, I wanted to have the top annotation we had before, but also the cell bar plot annotation we just created here. So as you can see, we are creating different annotations separately with the heat map annotation function, which we're assigning to different objects. And then we're very flexible because we can add or remove them as we wish here. So depending if we want them in the top or the bottom or wherever we want. So this is our heat map. So again, we split it. We have our patient IDs, our genes in our rows. And as you can see, we have a very nice bar plot annotation here with cell composition. And we still have this other top annotation as well, showing the age, BMI, tumor size, or gender. Hope you were able to see that. Now imagine we only want to show the cell bar plot annotation. That's really easy to show, just like this. Now we're only showing the cell bar plot annotation here. Or imagine we want to show the cell bar plot annotation in the top, and we want our other annotation with age, BMI and all that, we want it in the bottom. So we're just going to add that to the bottom annotation. So as you can see now, the bar plot is in the top and age, BMI, tumor size and gender are in the bottom. So super easy to control whether you add these annotations or not and where you add them to. Nice. And of course you can also control how this looks. So here it's in bold. You could also convert these to bold or remove them or change how they look like, etc. So another thing you might be interested in is editing the heat map width and the heat map height. And you can do that with heatmap width and heatmap height. So that will essentially control how wide or how high the heatmap itself is. Then you have another parameter, which is width and height, that controls the heatmap body. This controls all components except legends, and this controls only the heatmap, the width and the height of the actual body. So there's different ways you can control the width and the height. You can set it to absolute units. So for example, here I'm setting it to 12, or you can make it, for example, dependent on the number of columns and number of rows. So here I'm calculating the number of rows and columns of our expression data of our actual matrix, and that way it can control how big or how wide and high the heat map is. So what else? Another thing is the legend. So you can change the location of the legend with heatmap legend side. So having it in the left side or the bottom, or even not showing a heat map legend at all. And as we said, this only affects the heat map legend itself. The annotation legends should still be there. But you can also control whether those appear or not and how they appear. For example, I edited this legend, the heat map legend. So now the title is in blue and much bigger, and I can edit the annotations next to the bar. Nice. So sometimes you don't want to do unsupervised clustering, but you want to just order the heat map columns or rows using a custom order. So what we can do is order the heat map by its BMI. So first we'll order the patients by descending BMI. And then we'll get the order, so by pulling the patient ID. So I think I need to load the tidyverse first, or dplyr library. So now it should work. So this is the patient order ordered by descending BMI. So now we're going to order the expression data by this patient order. So if we now check our columns, let's just check the first 5. So as you can see, they're ordered by descending BMI. Great. So now when we add it to the heat map, it will use this custom order if we disable clustering. So we have to make sure we're not clustering columns, because otherwise the columns will be ordered by their clustering relationships, right? So great. And what we'll also do is add a text annotation. So I'll add an example where I add the sample and the patient's name. We're going to subtract patients. Instead of patient, we're going to have S for sample, and then we're going to have BMI and the patient's BMI. So it's a bit of a silly example, but it will do for now. And then we'll also add the age. And as you can see, we have some additional special annotations. So the same way we had anno text or anno bar plot before, now we have anno text because we just want to show text. And then we have anno points for point plots and anno lines for line plots. So there are more examples of these special annotations. We're going to run this heat map annotation, and again, if you just want to check how that looks like, you can call draw on the heat map on the annotation itself and draw the text annotation. So again, it doesn't look great unless you actually plot the heat map as well. But as you can see, you have the annotations, which are just a text annotation. You could have any kind of text, like this is just a bit of a silly example with the sample and the actual BMI of each patient. And then we have the point plots showing the age, and then we have the BMI. And remember that we ordered our annotations file also by descending BMI, so it's a descending line. And now we're going to put it all together and add this heat map annotation object to our heat map. So we'll just add it as a bottom annotation. So in bottom annotation, we have the text annotation. So let's try that. So it might be a bit too small. We might need to reduce once you print it onto a PDF or a PNG object, then you'll be able to see it nicer. But essentially we have our annotations here, and then we have our point plots showing the age, and then the descending line. So what we're going to do, just to be able to see it a bit better, just going to substitute this with the new heat map. Hopefully we'll be able to see the heat map then. Well, not great. There we go. But you can see the descending BMI line, and then the point plots for the age, and then the different text annotations. In this case, yeah, they're just text, and I disabled the actual labels and just have this instead. So yeah, there's plenty more examples of these specific or more advanced types of annotations: bar plots, point plots, density plots, violin plots, box plots, you name it. You can just add them to your heat map. You can control how you add them and how they look. So yeah, complex heat map is a very powerful tool for heat map annotations as well. So hopefully it will get easier over time, but essentially what you need is heat map annotation, and then for each annotation you want to add, whether it's text or point plots or line plots or bar plots, you just add a section that has anno text or anno points or anno lines. And yeah, within each one you have the actual data. So in this case, anno points will affect age. So you just add a vector of your age points. So that will be plotted, and then you can edit how this looks, the color, the size, etc. Great. So to finish up, I just want to show you this other library called Dendextend, which allows you to control the dendrogram. So the dendrogram is the tree-like structure that appears on the sides when you cluster your data, and you can control how that looks like too. So for example, what we're going to do is change the color based on a specific K, so a specific number of clusters. So we're going to color the branches for 4 different groups for rows and 3 different groups for columns. So now if we draw the heat map, and it's a very basic heat map, you can see that there's 3 different colors for the different branches for the columns and 4 different colors or groups for the dendrogram of rows of genes. So this is quite powerful as well if you want to highlight specific groups of either supervised or unsupervised clustering. And of course you can make the lines wider or shorter or whatever it is you need. So finally, to save your heat map, it's really easy. You just specify a folder. You can also save it to your current working directory, but essentially I use file path to specify my heat map file. So I'll just run this to show you, but if my path is this, then I can use file path to create the whole file name. But of course, instead of this, you could just type in the path file name. So this is equally valid. And then you specify the width and the height, and you can change these parameters depending on the size of your heat map, of course. In this case, I'm exporting it as a PDF, but you can also export it as a PNG file, JPEG file, or TIFF file, or whatever it is. And that is the end of this tutorial. Squid-tastic! In this video, we covered how to create publication-ready heat maps in R using the R package ComplexHeatmap. Hope you found it useful. Let me know if you have any questions. I leave a couple of useful links below. Their official documentation is really exhaustive, so I really recommend you check it out if you're looking for particular ways to show your data. And hopefully this tutorial gave you an idea of what is possible with ComplexHeatmap. I usually just Google when I want something specific, so don't get overwhelmed by the amount of customization options you have. But yeah, hopefully you found this post useful. Let me know if you have any more questions, and see you in the next one.